As you can see, several houses can be connected to the typical gravity sewer system. For maintenance purposes, inspection manholes have to be installed in 70-meter or 200-foot intervals. Additionally, each change of slope or direction requires a change of the nominal width, the material, junctions, and an inspection chamber. Due to the required slope, the depth of the pipe can be up to 6 meters or 20 feet, which leads to substantial installation costs. The construction costs greatly increase with each meter of additional depth. Here you can see a vacuum sewer piping network. Vacuum technology requires shallow installation depth. Vacuum pipes are installed just below the frost line and in consideration of traffic load above the pipe. Typical installation depth is around 1 meter or 3 foot. Costly inspection manholes are not necessary. The cost for the excavation of trenches is much lower for the vacuum sewer system. The installation of vacuum pipes is flexible and can accommodate ground surface conditions. The pipe slope is laid at 0.2%. After 100 meter or 300 foot, a lift will bring the pipe back up to the original installation depth. Instead of costly inspection manholes needed for gravity sewers, smaller inspection pits are installed every 100 meter or 300 foot and are covered with small street caps. The appearance is clearly more attractive and it is much easier to build the road surface. Here you can see two subdivisions that are separated by a lake. The subdivisions are not connected by a joint sewer network, therefore the lake has to be bypassed. The top view clearly shows that an inspection manhole is required whenever the gravity line changes direction. Inspection manholes generate additional construction costs. In this example, the groundwater is very high, resulting in increased installation costs as well. The wastewater is transported from right to left, while the terrain increases from right to left as well. Due to the difference in height between both sites, the wastewater shall be lifted by additional pumping stations, thus resulting in higher construction and maintenance costs. The overall cost of a gravity system compared to that of a vacuum system significantly increases due to the installation depth, additional inspection pits, additional electrical equipment, and their maintenance. In comparison, the same project is now installed with vacuum technology. The profile of the vacuum system follows the terrain, therefore remaining close to ground level. Several lifts are used. Because of the low installation depth, it is apparent the vacuum line can be laid above the groundwater table. The costs for excavation and safety measures are much lower. Because costly inspection pits are not necessary, the construction costs decrease significantly. The wastewater is transported from right to left and follows the terrain elevation. Pumping stations are not necessary. Costs are further reduced because no additional lift components and their maintenance are necessary. Now let us look at the terrain from above. The gravity sewer system requires inspection manholes for every change of direction. Vacuum sewer systems do not require inspection manholes, and the pipes are flexible and can be adjusted to each direction. The costs for installing a vacuum system are significantly lower. Considering both examples, important advantages of the vacuum sewer system are low installation depth, flexible pipe laying, unnecessary inspection manholes, no electrical equipment or its maintenance. Consequently, construction costs are much lower.